In this session, same geometry part, section formula, centroid of the triangle, centroid of the tetrahedron, based on that one problems. First section formula, consider O be the origin, OA bar is equal to A bar, OB bar is equal to B bar, joining the line AB bar, dividing section formula, we take a point on this AB bar, dividing in ratio, finding the position vector of the point in terms of A bar and B bar. OB the origin, OA bar is equal to A bar, OB bar is equal to B bar, joining a line AB bar connected. OA bar is equal to A bar and OB bar is equal to B bar. O is the origin. In the section formula, we define on a line L equal to 0, OA bar is equal to A bar, OB bar is equal to B bar, 2 points. Take a point P, divides AB in the ratio of 𝗪 internally. Let OP bar is equal to R bar be a point, divides AB bar in 𝗪 ratio internally. OP bar is equal to R bar, a point which divides AP bar in the ratio of 𝗪 and internally. Now, expressing OP bar in terms of A bar and B bar in the ratio of 𝗪. So, clearly we noticed that AP divided by PB is equal to L/M. In the geometrical diagram also we noticed that the point P divides AB in the ratio of 𝗪. Magnitude of AP will be L, magnitude of PB is equal to M. So, P divides AB in the ratio of 𝗪. So, according to the ratio, AP divided by PB will be is equal to L/M. On cross multiplication, we noticed that M times of AP bar will be is equal to L times of PB bar. By cross multiplication, we noticed that M times of AB bar is equal to L times of PB bar. Now, we express AP bar PB bar in the position vector, that is M times of AP bar. According to the last class we have discussed, the position vector of AP bar can be written as OP bar minus OA bar will be is equal to L times of, again PB bar can be written as OP bar minus OB bar. Our aim expressing OP bar in terms of L and M and A bar B bar. Now, separate OP bar. So, M times of OP bar minus A bar will be is equal to L times of B bar minus OP bar. Take out position vector of OP bar. As we took OP bar common, it will be M plus L will be is equal to L times of B bar and plus M times of A bar. Moreover, OP bar will be is equal to L times of B bar plus M times of A bar divided by L plus M. We know that L and M are the real numbers, they follows the commutative law. The point P divides AB bar in the ratio of 𝗪 internally, then the position vector of OP bar will be is equal to L times of B bar plus M times of A bar divided by L plus M. If P divides AB internally in the ratio of 𝗪, if P will be the midpoint, if P is midpoint of AB bar, you know midpoint means the distance between A to P and the distance between P to B will be equal, in the sense L will be is equal to M. L is equal to M, then the ratio is 1:1 ratio, means if P is the midpoint of AB, it divides AB in the ratio of 1:1. So, position vector of P is OP bar will be is equal to, as we kept L and M equal, that is L times of B bar plus L times of A bar divided by L plus L. Therefore, OP bar will be is equal to A bar plus B bar divided by 2. If P is the midpoint of AB bar, then the position vector of P bar will be is equal to A bar plus B bar by 2. When P divides, P will be the midpoint. If P internally divides, the ratio will be plus. If P, one note you can write here, that is, if P divides AB bar in 𝗪 externally, then the position vector of OP bar will be is equal to L times of B bar minus M times of A bar divided by L minus M. Any one of you tell me, if P will be the externally divides, but it is a midpoint, is it possible? P divides AB externally, but if it is in the ratio of 1:1, it is impossible. P divides AB externally in the ratio of L:M, but it can't divides in the same. What happened if it divides? P may be coincident with A or P may be coincident with B. So, midpoint for external not possible, only midpoint for the internal. P externally divides minus P internally divides plus. Finding the centroid of the triangle ABC. To find the centroid of the triangle, consider, let O be the origin, OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar are the vertices of a triangle ABC. Our aim, finding the centroid. Just now we did midpoint of the position vector, now finding the centroid. You know centroid, what is a centroid? In a triangle, point of intersection of medians we define as a centroid. First of all, we will prove that medians are concurrent, then we will calculate the centroid of the triangle ABC. Consider OB the origin, OA bar equal to A bar, OB bar equal to B bar, OC bar equal to C bar are the vertices of a triangle ABC. You draw one triangle ABC and define the origin. You may take the origin inside or outside of a triangle ABC. A bar, B bar and C bar are the vertices of a triangle ABC. To find the centroid, first we will define the medians. AD bar and BE bar are the medians of triangle. And we take that concurrency point of these medians as you name as G. So, AD bar and BE bar. So, what will be the position vector of OD bar? OD bar will be is equal to OB bar plus OC bar divided by 2. In the sense, OD bar will be B bar plus C bar by 2. The position vector of OD bar. Similarly, position vector of OE bar is equal to OC bar plus OA bar divided by 2, that is C bar plus A bar by 2, and we calculated the position vector of D and position vector of E in triangle ABC. Now, our aim to find the coordinates of centroid. First we will prove that medians are concurrent, then we will go for the centroid. You assume, let G is a point on AD bar. I took a point G. G be a point on AD bar, divides AD bar in 2:1 ratio. I took a point G on AD bar median, which divides AD bar in the ratio of 2:1. It is nearer to A, 2:1. So, according to the position vector, OG bar is equal to, just now we derived the section formula. According to section formula, OG bar is equal to 2 times of B bar plus C bar by 2 plus 1 times of A bar and divided by 2 plus 1. I took a point G on the AD bar which divides AD bar in the ratio of 2:1. We calculated the position vector of OG bar, that is 2 times of B bar plus C bar by 2 and 1 times of A bar by 2. As 2 ones are cancel. So, position vector of OG bar is equal to A bar plus B bar plus C bar divided by 3. We calculated G position vector with respect to AD median. Now, we find OG with respect to BE. Again let G divides BE bar in 2:1 ratio. First what I did, calculated the position vector of G with respect to the median AD. Now calculating G with respect to BE, it divides in the same ratio 2:1. Therefore, position vector of OG bar, now I am doing with respect to BE bar, will be equal to 2 times of A bar plus C bar by 2, 2 times of A bar plus and 1 times of B bar divided by 2 plus 1, as 2 ones are cancel. So, OG bar will be is equal to A bar plus B bar plus C bar divided by 3. We calculated G with respect to AD bar, we got A plus B plus C by 3, and we calculated G with respect to BE, and that also we got A bar plus B bar plus C bar by 3. What it indicates? The position vector of G is a common point of AD and BE. That common point we called as the centroid of the triangle. G, the position vector of G, A bar plus B bar plus C bar by 3, which is coincident with position vector of BE bar, A bar plus B bar plus C bar by 3. Similarly, if you define the other third altitude, the same thing we can able to prove. Therefore, in a triangle, in the vector method we can say that medians are concurrent, and the concurrency point of these medians we called as the centroid, and the position vector of the centroid OG bar will be is equal to A bar plus B bar plus C bar divided by 3, or you may write as capital A, capital B, capital C if you take the vertices. OG bar is equal to OA bar plus OB bar plus OC bar divided by 3. So, the relation sum of the vertices position vector OA bar plus OB bar plus OC bar will be is equal to 3 times of OG bar. In the vector method, we prove that medians are concurrent, and the point of concurrence of the medians we called as the centroid. The position vector of centroid will be A bar plus B bar plus C bar divided by 3. Tetrahedron. Consider one tetrahedron with vertices A, B, C, D. Let again O be the origin. And A, B, C, D is a tetrahedron consisting of 4 planes. A, B, C, D is a tetrahedron. So, it is constructed by A, B, C and D. A, B, C, D is a tetrahedron, and clearly it is noticed that there will be 4 triangles. ABC is one triangle, ACD is one triangle, ADB is one triangle, and CDB is the other triangle. For these 4 triangles, we can define 4 centroids. If we call G1, G2, G3, which is other side of the board, G4 centroids. And the line joining opposite vertex to the centroid of the triangle, that one we call as the median of the tetrahedron. As it is a space concerned, you can't see this median BG, BG1 and CG2, DG3, AG4 will be the medians. Same method earlier, how we proved that centroid divides median in the ratio of 2:1. Here the concurrency point of medians divides the medians of the tetrahedron in the ratio of 3:1. On applying the same method, so the centroid OG bar of the tetrahedron with vertices A, B, C, D will be OA bar plus OB bar plus OC bar plus OD bar divided by 4. If we take ABCD is a tetrahedron with vertices, if O is the origin and OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to C bar, OD bar is equal to D bar, then position vector of OG bar will be is equal to A bar plus B bar plus C bar plus D bar divided by 4. Earlier proof we did in the triangle, same proof which we take in the ratio of 3:1, you can prove that their medians are concurrent and the point of concurrence of the medians in the tetrahedron centroid A bar plus B bar plus C bar divided by 4. What is an internal angular bisector? Just now we define angle between the two vectors. If OA bar is equal to A bar, OB bar is equal to B bar, two coinitial vectors, and the angle also we define them. OA bar theta is the angle between AA bar and BB bar. What is an internal angular bisector? A line which divides angle between A bar and B bar into equally two parts, that is the internal angular bisector. Consider let OA bar is equal to A bar and OB bar is equal to B bar, two coinitial vectors. Define OA bar is equal to A bar and OB bar will be is equal to B bar, two coinitial vectors. Theta is the angle between. Now you define the internal angular bisector which divides internal angle into equally two parts. You name it as OD bar. First we are talking about the internal angular bisector which divides angle AOB into equally two parts. To find the position vector of OD bar, first you take unit vector of OA bar, you called as OA dash. Let OA dash be the unit vector of A bar, AA bar. So what is OA bar dash? OA dash bar is equal to A bar divided by mod of A bar in the direction of A bar. I took unit vector of A bar called as OA dash and unit vector of B bar, B dash. Let OB dash be the unit vector of B bar. According to the unit vector formula, OB dash will be is equal to B bar divided by mod of B bar. To be defined the unit vector. In order to calculate the position vector of internal angular bisector, you take their midpoint. We had one small property in the geometry we learned. What is the geometry property? Any point if you take on the internal angular bisector, it will be equidistant. So your OP bar will be the midpoint of these two, that is OA dash bar plus OB dash bar divided by 2. Internal angular bisector, any point if you take, it is equidistant. So OP is equal to, and what is the unit vector of this internal angular bisector? OP bar cap will be is equal to OP bar divided by mod of OP bar. So the vector OP cap will be is equal to A bar dash is nothing but A bar by mod of A bar plus B bar by mod of B bar and its magnitude, that is A bar by mod of A bar plus B bar by mod of B bar. This is the unit vector of the above internal angular bisector. So to get the internal angular bisector, its length will be depends. So therefore position vector of internal angular bisector OD bar will be is equal to lambda times of OP cap. OP cap is the unit vector of the internal angular bisector. If you multiply with the lambda, that gives the internal angular bisector of the angle AOB. Similarly, if you extend here external angular bisector minus A bar, and this will be the external angular bisector. Same, but in case of here A bar, this will be minus B bar, the midpoint here, which is B bar, and here will be minus, again midpoint. Same procedure you can able to find the external angular bisector unit vector and its position vector. We did internal angular bisector and external angular bisector. Earlier we did point of intersection of the medians in the triangle, point of intersection of medians in the tetrahedron. Now I will discuss definition of the internal angular bisector and in a triangle internal angular bisector. Triangle internal angular bisectors are concurrent. Just now we did in a triangle medians are concurrent, calculated the position vector of the concurrency point of the median centroid. Now we prove internal angular bisectors are concurrent and concurrency point position vector. Further define O be the origin, OA bar is equal to x bar, OB bar is equal to y bar, OC bar is equal to z bar. Vertices of a triangle ABC. Earlier also I told you, origin may be taken inside or outside anywhere of a triangle ABC. Draw one triangle ABC and define the vertices of the triangle ABC. A x bar, B y bar and C z bar are the vertices of the triangle ABC. Take their lengths. Let mod of AB bar is equal to C, the length, mod of BC bar is equal to A, the length, mod of CA bar will be is equal to P. Define the vertices and the sides of the triangle. Now our aim to prove internal angular bisectors are concurrent. Define the internal angular bisectors of A, B. AD will be the internal angular bisector. Divides into equally two parts, internal angle AD. AD will be the internal, and in the geometry we learned one small concept. Internal angular bisector D divides the side BC in the ratio of C:B ratio. D divides in the ratio of C:B, or you may call AB, mod of AB ratio, mod of AC. First we will find the position vector of T. So the position vector of D, that is OD bar is equal to, concluded that, or we in the geometrical concept we learned that D divides BC in the ratio of C:B. So OD bar will be is equal to C times of Z bar plus B times of Y bar divided by C plus B. The position vector of CD bar, OD bar will be C times of Z bar plus B times of Y bar divided by C plus B. Similarly, we define BE bar, other angular bisector, BE bar. Again, E divides AC in the ratio of A:C. The point E divides AC in the ratio of this side and that side. So the position vector of OE bar will be is equal to C times of Z bar plus A times of X bar divided by C plus A. So we calculated the position vector of median which meets BC and which meets AC. Now to prove they are concurrent, I wanted to take their one point I, and I divides, let I be a point on AD bar, divides in the ratio of B plus C and A. I divides AD bar in the ratio of B plus C ratio A. So OI bar will be is equal to B plus C times of OD bar, B plus C times of OD bar and A times of OA bar and divided by B plus C plus A. That is nothing but OI bar is equal to B plus C into OD bar. OD bar will be C times of Z bar plus B times of Y bar divided by C plus B plus A times of X bar and divided by A plus B plus C, because sides are real numbers, they follows the associative law, commutative law. So, one B plus C if you cancel, position vector of OI bar will be is equal to A into X bar plus B into Y bar plus C into Z bar divided by A plus B plus C, name it as number 1 equation. We calculated the position vector of a point on the AD. Similarly, I divides BE bar in the ratio of the position vector of OE bar. Just now we did OE bar is nothing but C times of Z bar plus A times of X bar divided by C plus A. Now you take I divides BE in the ratio of A plus C and B. Finding position vector of I with respect to BE. So again OI bar will be is equal to A plus C times of OE bar plus B times of OB bar and divided by A plus C plus B. First we calculated position vector of I with respect to the first median OI bar. Now we are finding I with respect to the second internal angular bisector BE, that is OI bar is equal to A plus C times of OE bar. OE bar will be CZ bar plus AX bar divided by C plus A plus B times of Y bar and divided by A plus B plus C. One C plus A cancel. Therefore, OI bar with respect to second internal angular bisector is AX bar plus BY bar plus CZ bar divided by A plus B plus C. You name it as number 2. And we concluded that there is a point I which is dividing AD and BE in some ratio, their vector points are coincident. That point of concurrency of the internal angular bisector we called as the incenter. Okay? In the geometrical method we prove that internal angular bisectors are concurrent. The position vector of internal angular bisectors OI bar will be is equal to A times of X bar plus B times of Y bar plus C times of Z bar divided by A plus B plus C. What are X bar, Y bar, Z bar? They are the vertices, whereas A comma B comma C will be the sides. Earlier class we did centroid OG bar is equal to A bar plus B bar plus C bar by 3 and internal angular bisector position vector OI bar will be is equal to A times of X bar plus B times of Y bar plus C times of Z bar divided by A plus B plus C, geometry by vector method. Okay, based on this one some problems we will discuss. G is the centroid of triangle ABC. Just now we calculated G is the centroid of triangle ABC and G dash be the centroid of triangle A dash B dash C dash. Then find the value of AA dash bar plus BB dash bar plus CC dash bar is equal to lambda times of GG dash bar, then find out lambda value. Repeat the question. G be the centroid of triangle ABC, G dash be the centroid of triangle A dash B dash C dash. This satisfies a relation AA dash bar plus BB dash bar plus CZ dash bar is equal to lambda times of g dash, then tell me the lambda value. So, take the resultant answer. Given that G is the centroid of triangle ABC. You draw one triangle ABC and define. Just now we did the proof of the centroid A, B, C. G is the centroid of triangle ABC. G dash is the centroid of second triangle. Centroid of triangle A dash, B dash and C dash. G dash be the centroid of A dash, B dash, C dash, G dash. According to the centroid formula, OG bar is equal to OA bar plus OB bar plus OC bar divided by 3. Just now we did proof. And this leads 3 times of OG bar is equal to OA bar plus OB bar plus OC bar. Put aside. Second triangle OG dash bar is equal to OA dash bar plus OB dash bar plus OC dash bar divided by 3. And moreover, on cross multiplication, 3 times of OG dash will be is equal to OA bar dash plus OB bar dash plus OC bar dash. Put aside. Now you wanted to find lambda, express this one in the position vector. Let LHS, the left hand side problem will be A dash bar plus B dash bar plus C dash bar, express into the position vector. That is A dash can be written as OA bar dash minus OA bar plus OB bar dash minus OB bar plus OC bar dash minus OC bar. Just now we did position vector of AB bar is equal to OB bar minus OA bar. Earlier classes also we did many problem based on that one. So, according to the vector addition, it can be written as OA bar dash plus OB bar dash plus OC bar dash minus OA bar plus OB bar plus OC bar. You express the value of OA OB in terms of the above result. On substitution we noticed that it is 3 times of OG bar minus and 3 times of OG bar dash. As we took 3 common, it will be G dash bar G. Therefore, your lambda will be is equal to 3. If G dash will be the centroids of both the triangle, the lambda is equal to 3. G is the centroid of triangle ABC. Triangle ABC, and GA bar plus BG bar plus GC bar is equal to lambda times of BG bar. Then tell me the value of lambda. Provided G is the centroid of the triangle ABC and A, B, C are the vertices. Okay, first you define OB the origin and ABC in a triangle ABC, G is the centroid. Draw one triangle ABC and define the centroid A, B, C. G is the centroid. GA bar plus BG bar plus GC bar is equal to lambda times of BG bar. Find out lambda value. So, G is the centroid we define. Now, take left hand side GA bar plus BG bar plus GC bar. So, in order to express this one, adding GB bar and subtracting GB bar. Added and subtracted. GB bar is the opposite vector of BG bar. So, it will be GA bar plus GB bar plus GC bar, writing these 3 vectors together, plus BG bar minus GB bar can be written as BG bar. As we expressed in the position vector, it will be OA bar minus OG bar plus OB bar minus OG bar plus OC bar minus OG bar plus 2 times of BG bar. Separate it. OA bar plus OB bar plus OC bar minus 3 times of OG bar plus 2 times of BG bar. In the first equation already we did by the centroid formula, OA bar plus OB bar plus OC bar is equal to 3 OG bar. So, this will be 3 OG bar minus 3OG bar plus 2 times of BG bar. So, one 3OG bar cancel. So, lambda will be is equal to 2. Calculated the centroid based problems, we did lambda. Earlier one problem. So, these are the geometric applications, how to apply the vectors in the geometry. A point P divides the line joining A is equal to A bar minus 2B bar plus 3C bar, and B in 2:1 ratio. Then position vector of B. A point P phi A bar plus 4B bar minus phi C bar by 3 divides AB in the ratio of 2:1, then the position vector of B. A point P divides AB bar in the ratio of 2:1, and the position of A is A bar minus 2B bar plus 3C bar, then find the position vector of B. So, according to the section formula, OP bar is equal to 2 times of OB bar plus 1 times of OA bar divided by 2 plus 1. 3 times of OP bar minus OA bar divided by 2 is equal to OB bar according to the section formula. Therefore, position vector of B, that is OB bar is equal to 3 times of OP bar is 5 times of A bar plus 4 times of B bar minus 5 times of C bar minus OA bar will be A bar minus 2B bar plus 3C bar and divided by 2 plus 1, that is 3. Therefore, the position vector of OB bar is equal to 15 times of A bar minus A bar, 14 times of A bar, and 12 times of B bar plus 2B bar, 14 times of B bar, and minus 15 times of C bar minus C bar, minus 18 times of C bar divided by 3, the position vector of the point B, which divides AB in the ratio of 2:1 internally. The position vectors of A and B are given by A bar and B bar. In the sense, OA bar is equal to A bar, OB bar is equal to B bar. Position vectors of 2 points A and B given A bar and B bar respectively. Position vector of point C is 5 times of A bar divided by 3 minus B bar. Position vector of points is 5 times of A bar by 3 minus B bar. Then what will be the location of C with respect to the triangle AOB and with respect to the angle AOB? Good point and good problem based on the vectors. Position vector of A, OA bar is equal to A bar, and OB bar is equal to B bar, two co-initial vectors. Locate the position vector of point C with respect to this triangle and the angle. So, to locate, express the point C midpoint format. The OC bar, given that OC bar is equal to 5 by 3 times of A bar minus B bar. To express in the midpoint form, multiply with 2, divide with 2. Then it will be 5 2s are 10, 10 by 3 times of A bar plus minus 2 times of B bar and divided by 2. To locate the position of the C, express in the midpoint form. 10/3 of A bar plus minus 2/3 of 2 times of B bar by 2. What is the meaning of this one? We extend A bar 10/3 times, 10/3 and approximately it will be 3.33, and extend this A bar 10/3 times, 10 by 3 times of A bar. Minus 2 B bar, minus 2 means it is negative in the opposite direction. This is B bar, minus 2 B bar, minus 2 B bar, and your C is 10/3 of A bar minus 2B bar by 2, and you take the midpoint of these two. OC bar. So, OC bar is equal to 10 by 3 times of A bar plus minus 2 times of B bar divided by 2. Now, tell me what will be the location of this C with respect to the triangle AOB and angle AOB. Obviously, we noticed that the point C will be outside C is outside triangle AOB, as well as C is outside this angle AOB also. If you extend this angle, it is outside angle AOB. So, the location of point C with respect to the triangle and angle, it will be outside. So, to find the location of the point, when it is given, you express into the midpoint form, then locate the point.